Welcome. I'm Teresa Tarbuck, Assistant Professor of Chemistry. In this video, we will demonstrate how to use titration to determine the concentration of an unknown solute based on its chemical reaction with a solution of known concentration. The process involves adding the known solution, the titrant, to a known quantity of the analyte, the solution with the unknown concentration, until the reaction is complete. Use a clean burette, then rinse the burette with titrant. Then discard the titrant. Refill the titrant in the burette. Be sure to measure the initial burette volume to 2 decimal places using a white card. We need to determine the volume of titrant required to just use up all the analyte. The analyte solution, in this case a strong acid, in an Erlenmeyer flask using a pipette. Now we'll add the titrant to the analyte. The first titration is a fast delivery of the titrant to the endpoint. The endpoint is identified by adding an indicator that changes color at the endpoint. Phenolphthalein is used in this case, but other indicators can be used depending on the reaction. Phenolphthalein changes from colorless in acid to light pink in base. The titration is complete when the solution changes to light pink. Be sure to record the final volume. The second titration involves a fast delivery to near the endpoint, then a slow delivery of the titrant while constantly stirring the solution to ensure all the solution reacts with the titrant. Make sure to rinse any splashes into the flask. We often see the solution change color suddenly at the endpoint. Use white paper under the flask to help detect this change. We'll repeat this process in our third and fourth titrations, obtaining the initial, then final volume at the endpoint. The goal is to get 3 good titrations to average. The difference in the volumes, the final minus the initial volume, for each trial should be within 1/10 of a milliliter of each other. We need 3 things to calculate the unknown concentration: the reaction equation, the volume of the titrant and analyte, and the known concentration. In this case, a strong acid was titrated with a strong base, sulfuric acid and sodium hydroxide. 2 hydrogen atoms combine with 2 hydroxide ions to make 2 water and a dissolved salt. Now we're ready to calculate the concentration using the following formula. We subtract the final minus initial volumes to get the volume titrated. 21.85 milliliters minus 9.50 milliliters gives us 12.35 milliliters. We take the average volume of the 3 trials, 12.30 milliliters. Next, the analyte volume is the pipette volume, 20.00 milliliters. We are now ready to solve the equation. We have the concentration of the strong base, 0.2235 molar sodium hydroxide. We know its average delivery volume, 12.30 milliliters. And we use the 2 from the reaction coefficients, 2 sodium hydroxide. The unknown concentration of sulfuric acid, we place an X in the equation. We know we pipetted 20.00 milliliters of that strong acid. The 1 comes from the reaction equation, as is the stoichiometric coefficient. Solving for X, we obtain 0.0687 molar sulfuric acid. Thank you for joining me to learn about molar concentrations of solutions in titration. To learn more chemistry, look at our other videos on chemical processes and formulations.